Hello, welcome all my dear student of TYBSc physics class. In previous lecture, we have studied Newton-Raphson method, it is numerical method. Now in this lecture, we are going to see numerical integration. Now question is arise that why numerical integration is important in computational physics. The antiderivatives of many functions either cannot be expressed or cannot be expressed easily in closed form, that is in terms of known functions. Consequently, rather than evaluate definite integrals of these functions directly, we resort to various techniques of numerical integration to approximate their values. Okay. So, consider definite integral of the form f of x is equal to integral x0 to xn y of x dx, or instead of y we can consider function f of x. Okay. And instead of fx here we consider I for integration. In this definite integral, x0 is lower limit and xn is upper limit, and this definite integral can be treated as the area under the curve y is equal to f of x enclosed between lower limit x0 and upper limit xn. Okay. This area can be determined by plotting a function on a graphical method. This area can be determined by plotting the function on graph paper containing grids and finding number of grids under desired boundaries like this. These are the grids. Okay. Now suppose we want to calculate the area under this. This is the function, and for this function, if we want to determine the area, and suppose this is the function, this is the function y is equal to f of x, this is the function, and the area under this function, that means this one, can be determined by plotting the function on graph paper containing grids. These are the grids. These are the grids. And finding the number of grids under the desirable or under the desired boundaries. Such a graphical method, rough values of area. It is also time consuming process and cumbersome. The better alternative to use a technique that uses simple arithmetic for calculating or for calculation using computer. What I say, the grid method, the graphical method is rough value of area. It is also time consuming and cumbersome. So the better alternative to use a technique that use simple arithmetic for calculating using computer, and this approach is called numerical integration or numerical quadrature. Okay. Now we are going to see first numerical integration, that is trapezoidal rule. What is trapezoidal rule? See here. consider a function y is equal to f of x. This function having interval x0 and xn. This is a continuous function, and this function or y is equal to f of x be a function having interval x0 and xn, equally spaced values of arguments x0 comma x0 plus h, or which is nothing but x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, and so on up to x0 plus nh, where h is the interval. Okay. We have to find corresponding values of y such that y0 is equal to f of x0, y1 is equal to f of x1, or sorry, f of x1, correct. Then y2 is equal to f of x2, such that yn, last is yn is equal to f of xn. Okay. Again I am going to tell you that here we are going to consider a function y is equal to f of x, and this is a function having interval x0 and xn, equally spaced value of arguments x0, then x1 is equal to x0 plus h, then x2 is equal to x0 plus 2h. In this way, last one is x0 plus nh, and we have to find corresponding values of y, that is corresponding value of y, that means y0 is corresponding to x0, and this is nothing but y0 is equal to f of x0, then y1 is equal to f of x1, then y2 is equal to f of x2. In this way, last one is yn is equal to f of x1. Okay. Now here we are going to use trapezoidal rule, okay, for finding the integration, and that trapezoidal rule is nothing but very simple: x0 xn integration, where x0 is lower limit and xn is upper limit, and y dx is a given function. According to trapezoidal rule, what we have to do, this trapezoidal rule is nothing but h upon 2, where h is the interval, then y0 plus yn plus 2 y1 plus y2 plus yn minus 1. Okay. Here this is nothing but trapezoidal rule, or this formula is known as trapezoidal rule. Now we are going to see one of the best example with the help of which we can understand trapezoidal rule, and this example is very important for exam point of view. So see here, what is the example? Use trapezoidal rule use trapezoidal rule with 4 steps to estimate integral 0 to 2 x upon under root 2 minus x square dx into dx. This is the function, and here by using trapezoidal rule with 4 steps we have to estimate the value of this integral. So solution is very simple. See, there are 4 steps. First one is y is equal to f of x is equal to x under root x upon under root 2 minus x square. Okay. Then second step is h is equal to x0 plus xn upon 2, sorry, xn minus x0, not plus, minus x0, where xn is the upper limit, this one xn, and x0 is lower limit, that is 0. And here, sorry, instead of not 2, here n is the number of steps. Here in this problem there are 4 steps. Therefore, here xn is equal to 2, x0 is equal to 0, and n is equal to 4 steps. Okay. So, if we put the value of xn as a 2 minus value of x0 is 0 and number of steps are 4, we have 2 by 4, that is 0.5. Then hence h is equal to, okay. Now we can calculate function y is equal to f of x. Okay. So first, for x is equal to 0, we have y is equal to f of 0 is equal to 0 upon under root 2 minus 0 square is simply 0. Okay. Now, when we substitute value of x as a 1, then we have y is equal to f of 1 is equal to 1 upon under root 2 minus 1 square root. So, this is nothing but simply 1 upon root 2, and this is nothing but 0.3333. When we substitute x as a 2, sorry, not this, see here, equal interval, 5 interval, 0, intervals are like this, 0, 0.5, 1, 1.5, 2. These are the intervals. So, first interval is 0, then obviously second interval is x is equal to 0.5. So, y is equal to f of 0.5 is equal to 0 upon under root 2 minus 0.5 square, and when we calculate this, obviously the result is like this, 0.3333. When we solve this, value of x is 0.5. Okay. Now, when we consider the x is equal to 1, then y is equal to f of 1 is equal to 1 under root 2 minus 1 square. Solve this, we get 0.5775 or 735. We can consider up to, sorry, we can consider 5 significant digit after decimal point. Now, if we substitute next value for x is equal to 1.5, then y is equal to f of 1.5 is equal to 1.5 upon under root 2 minus 1.5 square. Solve this by using calculator, we will get 0.7275, okay, or okay, 727607. Okay, and last, fifth, for is equal to, for x is equal to 2, then y is equal to f of 2 is simply 2 upon under root 2 minus 2 square. Solve this by using calculator, you will get 0. Very simple, 0.8164 up to 4 decimal point, and then 497. 8164497. Okay. These are the value of this one y0, y1, y2, y3 and y4. This value. Now, we are going to prepare a table for this result, and the table is very simple, or in another way we can tabulate these values corresponding to x0 in a tabular form. So, see here we get x 0, 0.5, 1, 1.5 and 2. Okay. Then here y is equal to f of x. First value 0 for 0. Then for x is equal to 0, function y is equal to f of 0.1 is 333, and for 1 like this 0.57735, and for 1.5 0.727607, and last one for 2 0.816449. This is the tabular form, and from this value we, by using the trapezoidal rule, we can obtain or we can estimate the value of this integral. So, trapezoidal rule is simply we studied integral y dx and x0 to xn is equal to h upon 2 in bracket y0 plus yn, okay, plus 2 y1, y2 up to yn minus 1. Okay, good. Now, simply substitute the value of h is 0.5 upon 2. Okay. Then y0 is 0 plus y1 is yn is, this is y0 and this is yn. So, yn is 0.816449 plus 2 in bracket value of y1 0.3333 plus again 0.57735 plus 7276707. This one. Okay, solve this. When you solve this, what we have to do? We have to only add this term, then multiply by 2, and the resultant value is added with this value, and then the final resultant value, for final resultant value we have to multiply by 0.5 and divide by 2. We will get the result is like this, 1 point. After making the calculation of this term we get 1.02 after 2 decimal point, then further 3.5 after 2.3.2.5.6. This is the estimated value of this integral. Okay. Now, I will provide you number of homeworks on our WhatsApp group. Now, from this method and from this example, we can prepare algorithm for integrating tabulated function using trapezoidal rule. Okay. That means what we are going to do? We simply write down the procedure in a particular form or logical sequence. So step 1, algorithm for trapezoidal tool. Step first. What we have to do in step first? In step first, we have to read the value of xn and x, sorry, or simply 1 and 2, where x1 is lower limit and x2 is upper limit. Okay. Okay. Then we have in step second or in step 2, we have to read the function, read y is equal to f of x. This is the given function, and also we have to calculate from this x1 and x2. That means calculate here, calculate function f of x1 and f of x2. In step 2, we have to read the first function, and from given function we have to calculate the value of f of x1 and f of x2. Then in step 3rd, read n, where n is number of steps for integration. Number of steps for integration. Okay. Then in step 4, after reading this, we have to calculate the value of h. Calculate value of h by using the formula h is equal to xn, or here not xn, x2 minus x1. In lower limit is x1 and upper limit is x2. We have to take the difference between upper limit and lower limit, that means x2 minus x1 upon n, where n are the number of steps. Then in step 5, we have to initialize the sum, that is sum is equal to 0. Otherwise it will take garbage value. Then in step 6, I is equal to 1, where I is loop index. We have to consider loop index. In step 7, what we have to do? We have to use the formula x is equal to x plus h into I. Okay. x1 not n. Okay. Then in step 8, what we have to do? We have to assign the value of sum into, plus f of x. We have to add the given function with the sum, and then the result is assigned to sum. Then we have to go for next step, and this will be done in step 9 as very simple, I is equal to I plus 1. That means again we are going to increase step by 1. Then we have to check the condition in step 10, and that step is nothing but if I is less than n, then go to step here 7. Okay. Again in step 11, we simply multiply by 2 to the sum and assign the result to the variable sum. Okay. And then last, in step 12, we have to use the trapezoidal rule and calculate the integral by using trapezoidal rule. Therefore, I for integration, simply here f of x1 plus f of x2, okay, plus sum into h upon 2. Okay. This is the trapezoidal rule. And then after then in step 13 we have to print the result, that is I, and in step 14 we have to stuff or end. In this way there is a very simple way to develop the algorithm, and I already told you that algorithm is nothing but the logical and correct procedure to determine or to estimate the value of given integral by using trapezoidal rule. Okay. Now we are going to develop the flowchart for trapezoidal rule, and trapezoidal rule, the flowchart, here we are going to develop a flowchart, and flowchart is nothing but the pictorial representation or graphical representation of this algorithm. So all the steps should be graphically represented in flowchart. So every steps can be picturized or graphically represented like this. So first step is start, then read, what we have to read, lower limit x1 and upper limit x2, and also we have to read the number of steps, that is number of steps for integration. Okay. Or here we have to also read the given function, and then so this is the reading block, input block, then read number of steps, and then calculate. This is the arithmetic box. Calculate h is equal to x2 minus x1 upon h, not h, n. Okay. By using this formula we can estimate, or we can calculate the interval. Okay. Then next step, we have to initialize the sum. So sum is equal to 0. By using this block we can initialize the sum. Also we have to initialize value of I is equal to 1. We do this in the same block. Okay. Then we have to use the formula. Which formula? x1 is equal to x0. Okay. Or simply x is equal to x1 plus I into h. By using this formula we can calculate the value of x. Okay. Now we have to assign sum into what? F of x. We have to multiply by this sum to given function and assign the result to the variable sum, and this is done by this formula. Okay. Now we have to increase, or we have to go to next step, and this will be done by using this block. So here, after then we have to decide whether, that is if I is less than n, we have to check the condition. If condition is true, then condition is go here. If yes, okay, and we have to come here, here. Okay. If no, condition is not true, then go further. Again, multiply by 2 to the sum and assign this result to sum, and this will be done by this block. Okay. Then simply display, then simply calculate the integration. I is equal to f of x1 plus f of x2 plus sum, and then multiply to this block by h by 2, and here we calculate the integration, and in next step we have to print integration, and then lastly end or stop. Okay, in this way we can draw a flow chart by using algorithm. Okay. Now in next lecture we will see the C program to calculate the integration, or to find out the integration, or to estimate the integration of given function. Till then we shall stop here. Have a good day. Thank you.